Hello.
Hello, good morning.
Good morning.
Lourdes. Lourdes,
Hola.
please start the Zoom.
Okay. I have a trouble with my camera. Give me 1 minute. Hi guys, do you hear me?
Yes.
Welcome guys. Enjoy the class. The class is going to be starting in 1 minute, okay? I have a trouble with my camera.
Emilia, your camera is off.
Okay.
Thank you.
So can we start the class?
Yeah,
Or-
please.
Morning.
Okay.
Okay.
Morning.
Morning.
Morning to everyone. So today we will have, first is the right triangles. So let's see what is a right triangle. So a right triangle is a triangle in which one of the interior angles is 90 degrees. And the longest side of the right triangle, which is also the side opposite the right angle, so this side here, is called the hypotenuse. And the two other sides are the height and the base. So usually we write it down like this, and it's really important to remember that the hypotenuse is opposite of the right angle. So it's opposite of the angle of 90 degrees. Because usually students get confused when they are solving area of triangles. Instead of taking the height and the base, they take the hypotenuse, and then the formula is incorrect, so the result is incorrect afterwards. So this is important for the right triangles. So there are different types of right triangles. We are going to talk about isosceles right triangles. This is a triangle that one interior angle measures 90 degrees and the other two angles are the same, or 45 degrees. Or it means that the base and the height of the triangle have the equal length. So for example, here, if the length of this triangle is 1 and the other one is 1, we can find how much is the other side, but we'll talk about that later. So we have that these sides are the same as well as the angles, and this is 90 degrees. As well, we know what we know else for the triangles is that the sum of the angles in each triangle, doesn't matter what kind of triangle is it, it's 180 degrees. So that's why these sides are the same. So the other triangles is scalene right triangles, and these triangles are the ones that interior angle is 90 degrees and the other two have different measurements. So this is the second picture. So the other measurements can be 30, 60, 50. the other one can be 40. So they can have different measurements. For this particular one that is on the picture here, like on the right side, we can know as well, because this angle is 30, is half of this 60. So that means that this side will be twice of this side. But we're not going to talk about this today. But anyway, just if someone is interested and wants to know, because we have that this side is 30, this angle is 30, and this angle is 60. So the opposite side of the 60 angle is twice the size of this 30 angle. So that's for the types of triangles. Now we have the Pythagorean theorem. So the Pythagoras discovers that the hypotenuse square equals the sum of the squares of the two sides in the right angle triangles. So the Pythagorean theorem is one of the most important theorem and is used a lot. We will see later. I will just firstly, so this is what it means. It means that if this length here of a squared, so the volume, like the area of this square plus the area of b square equals to c square, or the area of this big triangle. I'm going to use one YouTube video for you to see it. Let me show it here. It's really interesting one. I think you will enjoy it, and we can continue afterwards.
Hello, Emilia. Emilia.
Yes.
Yeah, you can continue, my dear.
Can I continue with the video?
You can continue, don't worry.
Yeah. I just wanted to show because it's interesting like this, the video. Okay, wait. I'll
Okay.
make it. So I think it was returned this one is to calculate the largest side one exercise. So the largest side of a triangle is 10 centimeters. That means that the hypotenuse is 10 centimeters. So if the height of the triangle is 8 centimeters, we should find the area of this triangle using the Pythagorean theorem. So I have write down here how is the area of a triangle. Is like the base times half of the base times the height. First, we need to find the base. So first we need the missing side in order to find the area. So how we can find the base? We can use the theorem. I'll put for base B. So we will have like the height squared, according to a theorem, if the height is A, height squared plus B squared should equal to C squared, or 10 centimeters is the hypotenuse. So we will have 8 squared is 8 times 8 is 64 plus B squared should equal to 10 squared is 100. Or now, in order to solve it, we need to subtract minus 64 from the both sides in order B squared to be alone. So we will get that B squared equals to 36. In order just to find how much is B, we need to find a square root of 36. And the square root of 36 has two solutions. One is minus 6 and the other one is plus 6. But in this case, we are talking about the triangle. So the triangle cannot have like negative sides. So the only solution will be 6 centimeters. So we will get that the base is 6 centimeters. Now we can find the area. Instead of base, I can put 6 centimeters. The height we know is 8 centimeters. So we can find the area. So the area of this triangle will equal to 1/2, or I will put just half below, sorry. So we have base times the height. The base is 6 times the height is 8. Or we can find out that the area is 8 times 6, 48, divided by 2. Or the area equals to 24 centimeters squared. Is this exercise clear to everyone? Okay, I guess so. I'll answer. So we can continue now with the next slide. So this was the Pythagorean theorem. We have another exercise involving this. So we have that the sides of the triangle are in the ratio 3, 4, and 5. That means, so this one, the smallest one will be 3. The next one will be 4, and the biggest one will be 5. So the ratio is 3, 4, and 5. And we know that the perimeter of the triangle is 840 meters. We need to find the area of the triangle. So first, in order to find the area, as we talked before, we need to know how much is the base and the height. So this will be the height, this will be the base, and this is the hypotenuse. So now we have, if I will put this one, C. So now in order to find the perimeter, knowing that all sides are in this ratio, we can put like b to equal to be 3x. Sorry. Equal. So b will be equal to 3x. The height will be equal to 4x. And the c, the hypotenuse, will be equal to 5x. So now the perimeter. The perimeter was everything around. We need to add all of them together. So b plus h plus c, or I can write down the formula directly. So 3x from b plus 4x from h and plus 5x from c. All of them together should give us 840. So now in order to find how much is the total, we can add this together. So we have 5 plus 4, 9, 12. We have 12x equals to 840. In order to find how much is x, we need to divide 840 by 12. So x will equal to 840 divided by 12, or just x will equal to 70. So now when we know that x is 70, we can find out how much is the base that we need and the height. We don't need the hypotenuse. We just need the base and the height because we are looking for the area. So the base will be 3 times 70, or the base will be equal to 210 centimeters. The height will be 4 times 70, or the height will equal to 280 centimeters. So now we can find the area doing this step. We have that the area will equal to the base 210 times the height, that is 280, divided by 2. I can divide this one, can divide the both of them by 2. And then for the area, we'll get that is 29 and 40. So 29,400 centimeters squared. Is this exercise clear? So every time that is given a ratio, we should use the we can use x in order to find if it's given the perimeter, we are adding them together. Or not, we can use the Pythagorean. For example, if it's given c and it's given the ratio, we can use the Pythagorean theorem in order to find it. I think it's clear for everyone. If not, let me know. So let me go to the next one. So this is like the use of Pythagorean theorem, why it's so important. So this one is used in calculation the steepness of the slopes of hills and or mountains. That means that the engineers usually use it, for example, when they're making the roads in each country, they're using to calculate the steepness of the slopes. You know, when you're riding like on the road, on the routes, and they're like saying like the steepness of this route is 10 degrees or 5 degrees. So you know how how is steep every slope. And then they're like is used in construction and architecture. So that means like here is that means like that all the time the engineers and architects use it in order to build buildings, to be strong, the buildings, and not to fall. They need to find how much is the right angle in order to calculate the length of the walls and everything. So they need to find everything, and they're using the Pythagorean theorem all the time. And as well, the astronauts use it to calculate the path of spacecrafts, rockets, and satellites. So in NASA, usually they use it like to find everything, like how it's around like the satellites and the other object in the space. Is it clear? Okay, so now we are going to talk about the other ones. I think for Pythagorean theorem, you understand how much is important and is used. So now we are going to talk about polygons, quadrilaterals, and parallelograms. So we know that a quadrilateral is defined as a two-dimensional shape with 4 sides, 4 verticals, or 4 angles. So these are some examples of quadrilaterals. So they means, so here's the name, it means 4 sides. Quad means 4 and lateral means side. So this is how the name came up. And what are some quadrilaterals in everyday life? Everything that is with 4 sides. So for example, tabletop, a book, a picture frame, a door, baseball, diamond. So there's so many like different shapes that are quadrilaterals. So now we are going to talk about the types of quadrilaterals. So there are several types that we can talk about. So the first one is the most used one to say, together with the square. So we are talking about rectangles. So the rectangles, we know that the opposite sides are equal, they're parallel, that's really important. So firstly, we can start with the parallelogram, because this is like the most used form of quadrilateral. And that is just quadrilateral that opposite sides are parallel and equal. So that means that the sides parallel to each other are equal and they're the same. So now from parallelogram comes up the rectangle. So the rectangle is parallelogram actually that has the angles 90 degrees because it's the same thing. There has opposite equal sides. Then we have the square is as well parallelogram that has angles 90 degrees and all the sides are equal. Then we have rhombus. It has all sides equal and opposite sides are parallel and all the sides equal. For rhombus and square are different because in rhombus the angles are not 90 degrees, so they're different ones. And the opposite angles are the same. So this one and this one and this one and this one are the same, as well as parallelogram. We know that the opposite angles are the same. So then we have trapezoid. Trapezoid is a quadrilateral that has one pair of parallel sides. The other ones are not. And it can be, so this one is quadrilateral, is not parallelogram because it has just one pair parallel sides. And a kita is adjacent pairs of sides are equal. So we have 2 sides are equal, but the ones that are next to each other. So we have these sides 2 are equal, this one are equal. And as well for kita is known that the angles where the 2 sides, different sides merge, they are the same. So these angles are the same. The other ones are not, but this one, yes. And the diagonals make a right angle here. So 90 degrees angles. So the one that I mentioned before, the squares, rectangles, and rhombuses are all parallelograms. So all of them are parallelograms because have 2 pairs of parallel equal sides. So for what else is important for quadrilaterals is that the sum of all the angles is 360 degrees. So, okay. So now we can solve like two exercises called quadrilaterals. So we can use this rule that I mentioned here, that the sum of all the angles is 360 degrees. We can solve the first one and the second one. Then someone wants to solve it or me to do it. Someone has some idea how to solve it, wants to help me to solve it. It's easy, this one. So we know that all the angles are, the sum of all the angles is 360 degrees. So what should I do? I just need to add all the angles. So the first angle I can put 57, plus the second angle is 97 degrees. The third angle is 131, and the fourth one is 15 plus 4x. Sorry, 15 plus 4x. So we should find how much is x in order to find the last angle. And we know that the sum of all of them is 360. So what we can do, we can add all these sides together. So 57 plus 97 plus 131 and plus 15. That's 300. And plus 4x. This is what we have on the left side, equals to 360 on the right side. Now we want here 4x to be alone in order to find how much is it. So we can subtract 300 from the both sides. And we can get that 4x on this side equals to 360 minus 300, that's 60. Or just x will equal to 15. So now we know that x is 15. Here is just looking for x, but we can find as well how much is the angle. So we can just put x inside here, the formula, and we can calculate. So it will be 15 plus 4 times 15. Well, that will be 15 plus 60, or will equal to 75. So 75 degrees will be the missing angle. This is one way to solve it. Now we can do the same way the second exercise. So let's do the second exercise. We solve it on the same way. So we have the first angle is 140 plus the second angle 110, third angle 62, and the fourth angle is 3 minus 5x. That will equal to 360. Now we can solve it, so we can add all of this together. We'll have like 140 plus 110 plus 62 plus 3. That's 315 minus 5x will equal to 360. So now we need to subtract 315 on the both sides in order to have minus 5x alone. So we will have here minus 315 on this side. And then on the other side, the same. So we will get, this one can be eliminated. On this side, we will have minus 5x will equal to 360 minus 315, that's 45. Or just x. We can divide by minus 5 on the both sides. And we'll get that x equals to minus 9. So now when we know how much it's x, we can put it inside here and we can find out how much is the angle, the missing angle. So I will have 3 minus 5 times minus 9. So we'll have 3 minus times minus will give me plus. 4 times 5, 9 times 5, sorry, it's 45. So the angle will be 48 degrees. Are this exercise clear? How to find the missing angle? Okay. So I can go afterwards. Sorry. Okay, now we will talk about polygons. So in geometry, a polygon can be defined as a flat or plane, two-dimensional closed shape bounded with straight sides. So it's important it doesn't have curved sides, and the sides of a polygon are also called edges. So we know that the sides, these are some type of polygons. They can be every type of shape. The important is that all the sides are straight lines. They are straight segments, not line. So it's if it has a curve, that means that it's not a polygon. So now we'll have like, depends on how many sides it has the polygon. We have different name for each polygon. For example, for if it has 3 sides, the polygon, as we know, is triangle, like this here, first example. Then we have, if it has 4 sides, is quadrilateral that we talked about before. If it has 5 sides, is pentagon. If it has 6 sides, is hexagon. Here we have 1 hexagon. So if it has 7 sides, is heptagon. 8 sides, octagon. 9 sides, nonagon, and 10 sides, decagon. As well, we have for 12 that is important is dodecagon, but that one is not. I haven't mentioned it here, but it's important. So these are the one that that have even numbers are more used. There are a lot. So we can have the classification of the polygons. So we have regular polygons. Regular polygons are that have equal sides and angles. So the side, when the polygon has equal sides and angles, it is called the regular polygon. So the first picture shows all regular polygons. So all of them have equal sides and equal. Irregular polygons, they have unequal sides. So their sides have different measurements and the angles are different. So this angle, for example, and this angle are different. This one is more noticeable. We have that this angle and this here are different and this here are different. So these are irregular polygons. So we have the classification on basis of the angles. That was in the basis of the sides. We have convex and concave polygons. So the convex polygon are all interior angles are smaller than 180 degrees. So all the angles inside are smaller than 180 degrees, each of them. And the concave polygon that at least one interior angle is greater than 180 degrees. So this angle is 100 greater than 180. So that's the difference. So now we have the sum of the angles in the polygon. So the sum of the interior angles in the polygon, we can find it out by this formula is n. If n is the number of sides, for example, if it has 5 sides, will be 5 minus 2 times 180, and we'll find how much is the sum of the interior angles inside. So all the angles together. And the sum of the exterior angles is always 360 degrees. So this is like also like really important rule, that because the outer angles, it doesn't matter if it's it has 5 sides, 6 sides, 7 sides. So the angle, the sum of the interior angles, so the angles that are outside, is 360 degrees. So now we'll have a pentagon, for example. How we can find out that the area is the sum of the angles 540. I can divide it on 3 triangles. Each of the triangles, as we know, has 180 degrees. So when I multiply that by 3, I will get 540 degrees. Or by using the formula is the same. So 5 minus 2 will be 3 times 180. So it's 540 degrees. We can do that for each kind of polygon. So as well for hexagon, heptagon. So I can each of the polygons divide on triangles, and we will always have 2 less triangles than the side that the polygon has. So now we'll have one exercise that we need to solve. So it says, find the measure of each interior angle of a regular polygon with 20 sides. So we have a polygon of 20 sides. We cannot write it down. We can use like the formula in order to find how much is the sum of the angles. And then it says interior, it's a regular polygon. That means that all the angles are the same. So first, we need to find how much is the sum of all the angles inside the polygon. So if there are 20, we can use the formula. So it will be 20 minus 2 times 180. And then we will have that the sum of all the angles inside 20 of a polygon of 20 sides will be 3,240 degrees. Now, what we know if the polygon is regular, what is important to notice? What we know about the regular polygons? What I mentioned before. Can someone tell me what we know about the regular polygons? So someone, yes, so all the angles are equal. You can talk, no need just to chat. So we know that all the angles are equal. So that means that I can divide. So if it's 20 sides polygon, it has 20 angles. So I can divide this 3,240 by 20 in order to find out how much is each angle. So if I divide 3,240 divided by 20, because it has 20 angles, so we find out that each angle has 162 degrees. Or we can write down as well a formula for angle, like finding how much is each angle, interior angle in regular polygon. That will be n if it's the number of sides in the polygon, minus 2 times 180. And then we divide it by the number of sides, sorry. So the number of sides n. So this will be like the formula to finding how much is one angle in the regular polygon. I think it's clear. We can go on the second exercise. On the second exercise, it says that the sum of the interior angles of the polygon is 1,620. How many sides does it have? So now it's given the opposite. So we need to find how many sides has the polygon. It's a regular as well. It doesn't matter if it's regular, like this is the sum of all the angles. So we can use the formula. We have n. We need to find how much is n, or the number of sides of the polygon. n minus 2 times 180 should equal to 1,620. So now I can multiply 180 by both of them inside. So 180 times n, that's 180 n minus 180 times 2 should be equal to 1,620. We have 180 n minus 360 equals to 1,620. Now, in order to have 180 n alone on this side, I can add, actually, because we have subtraction 360 here. So I can add 360 on the both sides. So we will have n 1,620, 1,980, or we can find out that now we should divide by 180 on the both sides in order to find how much is n, and we will have that n equals to 11. So how many sides does the polygon have? The polygon has 11 sides. Is it clear this to everyone? I guess so. So now, because every class I'm talking, just me talking, so now I'll give you one exercise for you to solve it. And you can, if you're shy to talk, you can write me the solution in the chat to see if you understand it. So, sorry. Okay, so I'll write 2 exercises for you to solve. One will be with the Pythagorean theorem. If someone doesn't have, have the formula, if needs the formula, you can write down. I can write down the formulas as well. So the first one is we need to find out. So find the area of right triangle with base 4 centimeters and hypotenuse C equals to 5 centimeters. So we need to find find the area of the right triangle given the base and hypotenuse C. And this is the first one. The second one will be with polygons. So find so we need to find the angle in regular polygon with 13 sides. So this is the first one. This is the second one. Does anyone need me to write down the formulas? I can write them down. So for the first one was a square plus b square, or the heights are here. I can height So the height squared plus b squared equals to the hypotenuse, c squared. And the area was the base times the height divided by 2. And for the polygon, we can know that 13 sides, we had the formula a minus 2 times 180 divided by n. So did someone solve the first one? So for the first one, pay attention is given the base and the hypotenuse. So does anyone solve the first one?
Hey guys, if you have some question, you can turn the microphone and you can ask the question to the teacher, okay?
Yes, can you use the microphone? It's easier. Like we should find, so we are missing here, like in the first one, we are missing the height. So this one is unclear. We know how much is the base is 4, and we know that C is 5. Don't forget, you need to square them. So when you square a number, you multiply it by itself, not by 2, by itself. Okay, one solve it correctly. Esteban. So let's have it. Does anyone else has solution except Esteban? Esteban, sorry. So how to find h? So how to find h? We are missing h. You just put it as it was. So we will have like h squared. This one is missing. So we're leaving as it is. We have plus. Instead of the base, I put 4. for 4 squared. Then that equals to C, that is 5. C is 5. And then I square that one too. So I will have that h squared plus, instead of 4 squared, I will put 4 times 4. That gives us 16. And that equals to 5 times 5, that's 25. Now, because on this side, on the left one, I just want to have h. I don't want this number here in order to find it. So I need to subtract 16 from the both sides, because here is with plus sign. So I need to subtract on the both sides. So we will have that h squared here plus 16 and minus 16, we can eliminate, equal to 25 minus 16, and that is 9. So h squared equals to 9, or just h will be equal to square root of 9. And how much is square root of 9? So which number, when you multiply by itself, will give 9? That's how you need to think. So when I multiply a number that I can multiply by itself to get 9. So that will be 3. Exactly. So h will equal to 3. The solution can be minus 3 as well. When you have like normal exercise, the solution can be minus 3 as well, because minus 3 as well squared give us 9. But in this case, no, because we are talking about triangles. These are real dimensions. So now when we have h3, we can just put it here inside the area, the formula of area, and we can solve it. So we will have the area will equal to, instead of base, I put 4. Instead of height, I put 3. And then I divide by 2. 4 times 3 is 12. Divided by 2. Or the area will be equal to 6. Okay, sorry, I will just do this. So the area will equal to 6 centimeters squared, because its area never forgets centimeters squared. Does anyone solve the second one? So the second exercise? So this is like the last exercise that I was solving with the polygon. This is the formula. So the upper part is just for all the sum of all the angles. And the down part is just for one angle, because they all have same angles. So does anyone solve the second one? Okay, I guess Esteban got it all. And the other ones? I should say Esteban, right? I guess so. Okay, Mateo, good job. So, let me see. Okay, for the one that doesn't know how to do it, I'll just explain. So we need just to enter instead of n, because n we said is the number of sides, is 13. So I just need to enter 13 inside the formula. So it will be 13 minus 2. For the ones who solve it, good job. All of you gave me correct result. divided by 13, because instead of n, I put 13. So we'll have 11 times 180 divided by 13. So I can solve that one, and the answer will be 152.3. So each of the angles in the regular polygon of 13 sides will be 152.3 degrees. So this was for today. Does anyone have questions? Because we are finishing with the class. It was everything. Was it everything clear or not so much?
Guys, do you have a question? Is clear for you, the class? Everything is clear? Clear? Camila said everything is clear.
Yeah, I'm thinking. Okay, great. Great.
Thank you so much, Emilia.
Thank you too.
Excellent class. Congratulations. Hey guys, thank you for being here. Have a wonderful day for all of you, and be pending for next class, okay? For today, 3 p.m. Have a wonderful day, teacher. I see you next class.
Okay. See you. Bye, guys.
Bye, guys.